Far beyond the orbits of the planets, the sun diminishes to no more than a single, faint star in an ocean of blackness. This is the realm where Voyager 1 now drifts, a region of perpetual night that no human-made instrument had ever touched before. Researchers had braced for a void. Instead, the plucky probe encountered invisible waves, shifting densities, energetic particles, and an eerie, persistent hum running through the interstellar plasma, like a heartbeat pulsing beneath an otherwise silent abyss. The discovery was puzzling enough. But then Voyager uncovered something even more disconcerting. The Great Barrier encircling our solar system is not entirely sealed. The galaxy beyond is still whispering and interacting with the space we call home. Designed to function for only a handful of years, Voyager 1 now, in 2026, stands as perhaps the sole machine capable of revealing what truly lies beyond the sun's protective embrace. Our sun constantly flings charged particles into the cosmos. This torrent, known as the solar wind, expands past every planet, crafting an enormous cocoon called the heliosphere. Every world, Earth, Mars, Jupiter, Saturn, and even the distant Kuiper Belt, resides within this sun-shaped bubble. For ages, scientists assumed the outer rim of this bubble would mark a clean, simple transition. The solar wind would taper off, interstellar particles would take over, and a spacecraft crossing the threshold would move from one predictable realm into another. Voyager 1 reached that frontier in August 2012. Its sensors registered a sharp plunge in sunborn particles and a dramatic surge in galactic cosmic rays. The probe had crossed the heliopause. Humanity had, for the first time, placed a working machine beyond the sun's magnetic shield. Yet Voyager did not glide into the calm interstellar waters that theorists had sketched. Instead, it entered a zone riddled with disturbances, pressure swings, and invisible structures that no model had foreseen. The boundary wasn't the end of the enigma. It was where the enigma truly began. In 2017, Voyager's plasma wave detector picked up a faint signal enveloping the spacecraft. At first, it seemed too subtle to matter, but the tone refused to fade. It persisted as Voyager cruised hundreds of millions of miles deeper into interstellar space. That emission gave scientists an almost continuous way to gauge the density of the surrounding plasma. Before that, researchers could only measure interstellar density during rare moments triggered by powerful solar outbursts, isolated snapshots at best. Voyager was now revealing a living, evolving landscape. Density rose and fell along its path, rising and falling as the craft crossed different zones, suggesting that interstellar space contains layers, undulating waves, and colossal structures woven from charged particles and magnetic fields. In essence, the gap between stars appeared to have something akin to weather, not rain or wind in the earthly sense, but variations in pressure, density, and energy sweeping through the galaxy. Scientists still aren't sure what generates that persistent signal. It might spring from natural oscillations within the plasma, or it could point to a more intricate mechanism that current theories can't fully capture. Voyager uncovered the pattern, but deciphering it may demand measurements the spacecraft simply doesn't have time left to make. The heliopause was supposed to separate two distinct magnetic territories. Inside, the sun's field held sway. Outside, the galaxy's magnetic influence should have taken command. Voyager discovered the transition was far messier. Near the boundary, solar and interstellar magnetic fields appear to intertwine through a process called magnetic reconnection, where field lines snap, rearrange, and unleash energy. The solar system isn't magnetically isolated from the galaxy. The two environments are linked. Voyager also detected extremely energetic particles near the heliopause, creating conditions far more violent than the gentle handoff scientists had anticipated. Although the plasma is too thin to burn like ordinary fire, the particles carry immense energy. This frontier behaves less like a quiet border and more like a collision zone. That matters because the heliosphere helps shield Earth from high-energy cosmic radiation hurtling through the galaxy. Voyager hasn't shown that this shield is failing. It has shown that scientists don't yet fully grasp the forces acting upon it. The sun is moving through an interstellar environment that shifts over time. As the pressure and density outside the heliosphere fluctuate, The protective bubble around our planets may expand, contract, or morph in shape. Voyager's improbable discoveries, then, are not just about distant space. They're about the invisible system that protects life on Earth. In late 2023, Voyager 1 suddenly stopped transmitting readable scientific data. NASA could still detect a signal, but the information inside had become gibberish. The spacecraft was alive. Its voice had simply turned unintelligible. Engineers eventually traced the glitch to a damaged chunk of memory inside the flight data system, a tiny chip degraded by decades of radiation and nonstop operation. The defective part couldn't be replaced. Voyager was over 15 billion miles away. A command takes roughly a day to reach it, and the reply takes another day to return. Every diagnostic attempt consumed nearly 2 full days. NASA engineers crafted a solution that sounded nearly impossible. They split the corrupted software into smaller pieces, relocated those fragments into different functional areas of Voyager's memory, and rewrote the spacecraft's instructions so the scattered code could work together again. In 2024, coherent data flowed back. Voyager began speaking clearly once more, but its remaining time is finite. The plutonium generators that power the craft lose electrical output each year, forcing NASA to deactivate instruments one by one. And on November 18, 2026, Voyager is expected to reach 1 full light day from Earth. A message will take 24 hours to find it. Its answer will require another 24 hours to return home. By then, every conversation with Voyager will span 2 days, and no one will know which reply will be the last. Voyager 1 isn't being defeated by distance. It's being defeated by time. Its electricity comes from 3 radioisotope generators that convert heat from decaying plutonium-238 into power. At launch, they supplied enough energy to run cameras, scientific instruments, heaters, computers, and communication systems simultaneously. Now, available power drops by about 4 watts every year. That may sound trivial, but aboard Voyager, 4 watts can decide whether an entire instrument lives or dies. NASA has already switched off most of the systems the spacecraft carried in 1977. Each choice preserves power for the remaining tools, yet permanently removes one way of observing interstellar space. Engineers are now exploring an experimental reconfiguration, sometimes nicknamed the Big Bang. Instead of tweaking Voyager's electrical systems gradually, the procedure would change several components in a coordinated sequence, cutting wasted power and potentially creating enough margin to extend the mission. But Voyager was never built for this kind of operation. Any unexpected fluctuation could trigger automatic protection systems, shutting down equipment before engineers on Earth even realize something has gone wrong. At Voyager's distance, there is no instant fix. A command travels for nearly a day before reaching the spacecraft. The response requires almost another day to return. NASA is trying to preserve a machine it cannot touch, using electricity it cannot replace, while communicating across a delay measured not in seconds but in days. Voyager's persistent plasma signal has created the first continuous map of density changes inside interstellar space. But that map remains unfinished. Researchers still don't know whether the emission comes from ordinary thermal oscillations in the plasma or from quasi-thermal noise, a different mechanism that could force scientists to rethink how the interstellar medium behaves. Solving that mystery demands more data. Voyager may not have enough power to provide it. No modern probe is following behind. No replacement spacecraft is approaching the heliopause. And a new mission could take decades to reach the territory Voyager already occupies. When its final scientific instrument shuts down, humanity won't simply lose an old spacecraft. We will lose our only active observer inside that region of the galaxy. The last signal may contain nothing dramatic, perhaps just another measurement of plasma density, temperature, or magnetic activity. But once it arrives, Earth's antennas will point back toward Voyager and wait for the next transmission. Hours will pass, then days, and eventually the silence will confirm that the longest conversation in the history of exploration has ended. Voyager itself will keep moving. Bolted to its side, the golden record carries human voices, music, natural sounds, and a map pointing toward the world that built it. The spacecraft will no longer be able to describe the darkness, but it will continue crossing it. bearing evidence that humanity once reached beyond its star's protection and discovered that the universe outside was far stranger than anyone imagined. Voyager 1 was never meant to be humanity's messenger between the stars. Yet nearly 50 years after launch, it is still revealing a frontier filled with turbulence, invisible structures, and forces our models never fully predicted. Its power is ebbing, and one day the signal crossing billions of miles will arrive on Earth for the final time. But until that moment, Voyager remains alone in the dark, listening where no other spacecraft can. Subscribe to the channel and turn on notifications, because Voyager 1 is still sending answers from beyond the sun, and its final transmission may hold the most important discovery of the entire mission.